Hello everybody, welcome to this video in which we will be illustrating the use of formulae in Excel. These 15 formulas that you see on the screen, some basic math and stat formulae and some logical formulae are the ones that I will be illustrating today. We will be using this data set, which is a data set that contains sales per store data for the top 24 fast food chains in the United States in 2012. Right, so let's begin. Okay, so I have copied the list of formulas from the Word file into the Excel file here, and we will go over all of these formulas and how to implement them in Excel using the data that we have. Okay, so the basic one thing you always remember when writing formulas in Excel is that you always begin a formula with an equal to sign. Right? So let's add a couple of numbers. So let's see. So what do I mean by beginning a formula with an equal to sign? Let's say that I want to add the sales per store for Bojangles and Boston Market together, and I want the result to show up in this cell right here. I have two options. I highlight the cell here, and then I start writing the formula for adding the two numbers. You start the formula with an equal to right there. That's one option. Or the other thing that you can do is you highlight the cell right here and then use this field right here. So this is the function, the formula bar. So you can type in right there and start writing the formula by putting an equal to sign there. Anything that you type up here will show up here and vice versa. Right? So let's start. So by saying equal to, you're telling Excel that you're going to write a formula that is going to do something with a bunch of numbers or even a bunch of text. So let's begin with adding two numbers. Like I said, I want to add the two numbers together, the sales per store of Bojangles and the sales per store of Boston Market. I want to add them together. Well, the first thing I can always do is just type in the numbers and add them together. So this is 1,780,000. Right, that's for Bojangles, plus 1,184,000 for Boston Market. So you can add the two numbers together. It is 2,902,000. Right, so that's the number that I have. Now this is one way of doing it, but this is obviously the less efficient way of doing it because these numbers are already here. The other way of doing it, and this is the traditional way of doing it in Excel, is when you're adding two numbers that already exist in one of the cells in Excel, what you do is you say equal to and say I want to add this number, click on it, plus I want to add this number, and then press enter, and that will give you the answer. Now there are a couple of ways of going about it. I took my mouse and I clicked on the cell when I wanted to choose cell. This is column B row 2 and column B row 3. So when I wanted to select B2 and B3, I clicked on the cell. The other way of doing it obviously is you could just type in, you could say B2 plus B3. Again, this is in my view a less efficient way of doing it. Clicking with the mouse is obviously faster, right? And there you go. So that's a simple formula. We have written our first Excel formula. Now, just like we're adding these numbers, we can subtract two numbers. We can say I want to find the difference in sales per store for Bojangles and Boston Market. So I can say B2 minus B3. Again, you'll notice that I began the formula with an equal to sign. So you always begin mathematical formulas with equal to signs. So begin mathematical formulas with equal to signs and write them down. And the simple formulas are obviously adding, subtracting, multiplying, and dividing numbers. So that's what we're doing here. There you go. So the difference between Bojangles and Boston Market is 534,000. So Bojangles had $534,000 more in sales than Boston Market per store in 2012. Right? Okay. Now multiply. So let's say that I want to multiply two numbers together. I want to find out. Let's say that just for the sake of argument, in the Philadelphia area. Let's say in a particular neighborhood, there are 10 Bojangles stores and 8 Boston Market stores. So let's say that there are 10 Bojangles stores and 8 Boston Market stores, and I want to find out what was the total sales for Bojangles in that area. So we know that the sales per store was 1,718,000 and there were 10 stores for Bojangles. So I can multiply the two together. Again, I begin the formula with an equal to. I take that, I multiply it with 10. And so the total sales for Bojangles in that area, so let's say the Philadelphia area. I don't think there is Bojangles in Philadelphia, but let's, for the sake of argument, assume it's the Philadelphia area. So the total sales is 17,118,000. So you just multiply the two together. You will notice that when you do multiplication, as we are used to, you usually put the X sign, the multiply sign. Obviously, we can't do that here in Excel because X is a letter which represents something else. So the function, what you use here instead of the multiply sign is you use the asterisk sign. So you use asterisk to multiply these two numbers together. Right? Let's say that I want to find out. We can do the same with the Boston market. So I can say that the sales per store was 1,184,000 and there were 8 stores in the area, so the total sales were 9,472,000. Right? So that's as simple as that. Always begin the formula with an equal to and then add, multiply, subtract whatever you want together. Right? Okay, so divide. So let's say that we obviously know that Bojangles made more money per store than Boston market. We want to find out at what ratio. So how much more money did it make? We know the absolute value to be $534,000, but at what ratio? So we can find that out. So we can say equal to, I'm going to take the sales for Bojangles. I'm going to divide that. So the division, symbol for division is the slash symbol. So the slash symbol we write next to shift. So it's slash symbol. So it's the forward slash and not the backward slash. You don't use the backward slash, you use the forward slash. So Bojangles divided by the sales for Boston market. So B2 divided by B3. And there you go. So this tells me that Bojangles made 145% of the money of Boston market. So the ratio of Bojangles sales per store to Boston market sales per store was about 1.45. Right? So that's the division function. Now, let's proceed. Okay, so in the first formula that we wrote, we had, when we add these two numbers together, we just said cell B2 plus cell B3. That gave us the total sales per store for Bojangles plus Boston market. But what if we wanted to add the sales per store of all the 24 for fast food chains that we have? What if we wanted to add all of these numbers? Obviously, you can do that in the simple, the same way that you did, where you say this number plus this number plus this number plus B5 plus B6 and so on. But that obviously, as you can see, can get old very quickly and is very time consuming. So a better way of doing that is to use something called the sum function. The sum function, as the name suggests, sums or adds numbers together. And so instead of writing individual numbers and adding them together with a plus sign, what I'm going to do is I'm going to write a function. So again, even that, anything math related always begins with an equal to, and then I'm going to write something called a sum function. So I'm just going to say sum. As I start typing in, you'll notice that there are all of these different functions that show up, but we are just doing a simple sum function. So when you write a function, the first thing that you do is you have an open parenthesis. Open parenthesis says that this is where all the values that go into this function are going to be. So we want to add a bunch of numbers. So all of those numbers are going to be listed within parentheses, right? So now listing the numbers within parentheses, again, you have a couple of options here. So I can say the first number, comma, the second number, comma, the third number, comma. You'll notice that it gives you ideas of what you should be doing within the parentheses. So it's going to say, okay, you should have one number, then you should have a second number, a third number, fourth number, and so on, and then it'll add all of those numbers up for you. Now, if you're doing this individually, this is just as bad as writing the plus signs, the a formula with plus signs individually. So instead, what we can do in Excel is, you want to add a bunch of numbers. You just choose them all. So you left click on the first number, and then you drag your mouse all the way down. So you choose this whole bunch of numbers. So it says B2 colon B25. So it says starting from B2 all the way up to B25. And I'm going to close my parenthesis. So open parenthesis, close parenthesis. All the numbers within the parenthesis, you want to add all of those numbers. I'm going to press enter, and boom. So sales per store for the top 24 fast food chains in the United States in 2012 was 41,782,000. Right? That's the number that we have. And instead of having to type in all these 24 numbers individually, or typing in a formula by clicking on 24 different cells, we just use a single sum formula and chose a bunch of these numbers all at once. Right? So that's the sum function. Oh, oops. Okay, now the next function that I have on the list is called the count function. The count function is an interesting function. I am going to show you a different version of the count function also, but let's begin with the count function. What the count function does is, when you choose a group of cells, it's going to count how many of these different cells in Excel have numbers in them. So if I say count, and this is useful to know how many numbers you have. If I say count and I choose all the sales numbers, right? I know that I have 24 cells. I have 24 sales values, right? 24 values of sales per store. And that's exactly what the count function is showing. Again, you'll notice that I began the formula with an equal to sign. Then I typed in count. That's the name of the function. And then I chose a list of these numbers, saying that, okay, out of these 24 cells, how many of them have numbers in them? Now, mind you, this only counts numbers. So instead of saying B2 to B25, so starting at B2, ending at B25, instead of looking at all of these numbers, let's say that I make this bigger. Instead, let's say that I say, don't start at B2 and end at B25, but instead start at A2 and end at B25. So this way I'm choosing all the names of the chains and sales per store, starting from A2 all the way up to B25. So if I use the count function here, you'll notice that I get the exact same answer. I still get 24, because even within these 48 cells that I chose, 24 of them are just names of the companies. Because they are names, they're not numbers. There are only 24 numbers, and that is what the count function counts. And that's something to remember. Count function only counts numbers. Now, what if you wanted to count everything? You just wanted to see, I have all of these bunch of cells. I want to know how many of them have something in them. Not just numbers, maybe even names of companies or something else, right? So the way you do that is by using a version of the count function called the COUNTA function. So let's look at the COUNTA function. So it is simple. You just say count A, as you see, count A. And if I choose the same cells again, the names of the companies and the stores, this time you will notice that it is going to say 48, because you'll notice 24 cells have names in them and 24 cells have numbers in them. So count A function, this function with all of these in parentheses, it's going to look at all of the cells and see how many of them have something in them, right? And obviously there are multiple versions of this function. So here we are counting how many numbers there are. If you wanted to look at a bunch of cells and see how many blank cells you have, there is a function called count blank, and so on. So I'm only going to go over the basic functions here. There are more advanced versions of each function. As you saw, even with the sum function, there are some 15 versions of the sum function that does more advanced stuff. I will leave that to you or to somebody else to explain that. So this is where we do the basics, right? Okay, that's the count A function, right? Now let's continue. Now we'll be looking at the min function, the max function, and some functions that are usually considered as statistics functions. So let's begin with the min function. So the min function, so out of all of these numbers, if we wanted to find out which store had the least sales, or what were the least value of sales of all the top 24 stores, well, I can use the min function. So I can start here and say equal to, again, all functions begin with equal to. I'm going to say min, M-I-N, the minimum of all of these numbers right here. Again, I can choose all the numbers, just click on the first one and drag my mouse all the way down to the last one. So between B2 to B25 of all of these numbers, what was the minimum value? And you'll notice that that is 1,103,000. 1,103,000, that's Moe's Southwest Grill. So Moe's Southwest Grill had the least sales per store in the top 24 fast food chains in the United States. So similarly, I can find the maximum value. So I can write the max function. So again, start with an equal to, type in max, choose all the numbers, press enter, and max is 3,158,000, and you'll notice that 3,158,000 is right here, and that is Chick-fil-A. So Chick-fil-A had the maximum sales per store, while Moe's Southwest Grill had the minimum sales per store. So remember, we are looking at the top 24 fast food chains. So they are doing better than, so there are hundreds of fast food chains in the country. So these are the top 25. So when I say minimum, I'm not saying it's doing badly. So just keep that in mind. Okay. Now, let's say that I wanted to find the average value of sales per store. So in the next three formulas that we're going to look at are basic statistics formulas. So we'll be looking at the average value, the median value, and of course the standard deviation. So the average value, is where you add all the numbers and divide by the number of numbers. So you could write a formula for average exactly like that. So you could say sum all the numbers and divide by the number of numbers. So I can either type in 24 for the number of numbers, or I can type in count and count the number of numbers, but I don't have to do any of that. Instead, there's a formula in Excel that calculates this average for you, and that is average. So I can just say AVE, the average formula. So I say average and choose the group of numbers going from B2 to B25, all of them right there. And that gives me that, tells me that for the top 24 fast food chains in the country, the average sales per store was about $1.74 million, $1,740,917 and probably a few cents. I'll show you that 67 cents, but that's unnecessary, right? So that's the average value, 1,740,917. So I can find the average again by saying equal to, writing the average function, and then remember the open parenthesis and the close parenthesis. Within parenthesis is where you say, okay, these are all the numbers of that I want to find the average for. And that gives me the average value, right? So again, so the average values, you're adding all the numbers and dividing by the number of numbers. You'll notice that many of these stores have sales per store between 1.7 and 2.2 million-ish. So there are a few stores that are over 2.2 million, and there is one store, Chick-fil-A, which is over 3 million. There are no other stores that are over 3 million per store. So just that one store, Chick-fil-A, over 3 million is pushing up all the values. So that's the average value where you're actually using the numbers. Now the other statistical formula that is commonly used is the median formula. So the median formula is the middle number formula. So you look at a list of numbers and you find the middle number. So 50% of numbers are bigger than the median and 50% of numbers are less than the median. So what's the middle number? So again, the formula is just going to be median, and I'm going to choose all the numbers that I have going from B2 to B25. That's median. You'll notice that the median sales per store is 1.592 million, and so that's the median sales per store. So half the top 24 chains, about 12 of them, will have sales more than 1.592 million, and 12 of them will have sales less than 1.592 million. Right? And finally, standard deviation. So again, standard deviation tells you how spread out the values are, and the way you write the standard deviation formula. So there's a slight technicality here, but the standard deviation formula is, so if you start typing in, you'll notice that it's STDEV. So I can just say STDEV, and I can choose the bunch of numbers here, and it'll give me the standard deviation value, which is 558,990. That's the standard deviation value. You will know from statistics that there are two types of standard deviations. One is a standard deviation for a population, and the other is a standard deviation for a sample. What that means is that if the data that you have, like right here, where the data is for a sample, a small portion of all the data, which is all the fast food chains in the country, then the formula for standard deviation is slightly different than if you had the data for all the fast food chains within the country. So there's a difference between population standard deviation and sample standard deviation. So when we write the STDEV formula, Excel automatically calculates a sample standard deviation, which is what it assumes, that the data that you have is a small portion of the whole data set. And if you do have the whole population, the way you write the formula is you say STDEV dot P for population. So you say STDEV dot P, and then if you choose all the values, it'll give you the population based standard deviation. Now this is obviously not the right formula here, but in case you needed the standard deviation for the population, you do dot P. Now the other formula is, if you wanted to do sample standard deviation, you can always do dot S, but that will give you the same answer as what you had here. Say for example, just to check, if you look at this right there, there you go, gives you the same answer right there. So that's the formula for standard deviation. So if you do STDEV, it gives you the sample standard deviation. If you wanted the population, you could do the dot P. You could add dot P to the formula. Right. So there are four more functions that I want to talk about. It's the if function and everything associated with the if function. So let's get to it. The first logical function that we'll be looking at is the if function. So the if function is a very commonly used function, and the way it works is so if I type in the if function, it's a simple way to illustrate this. So I'll say equal to if. You'll notice that there are three numbers here. There are three things that are required for the if function. So you conduct a test, and then you say, well, what happens if the test is true, and what happens if the test is, well, not true, or test is false, right? So what is a logical test? A logical test comes from the fact that when you're comparing two numbers, there are only three possibilities, right? The three possibilities are: the first number is equal to the second number, the first number is bigger than the second number, or the first number is smaller than the second number. Those are the only three possibilities. So given that, when you're comparing two things, you end up with the same three possibilities, and that is what a logical test is. You conduct a test, and in a logical test, the results are always true or false. So let's begin. So let's begin with the logical test. So in this case, let's say that I want to test to see if the Bojangles store has sales of more than 1.7 million. Now obviously I know that the sales per store for Bojangles is more than 1.7 million, but let's say that the number was not readily available on the screen. How would I write this function? So let's say if this number is bigger than 1.7 million, so that's 1,700,000, right? Then I wanted to say yes. You'll notice that because what I want to say is text based, I have to put it within parentheses. If instead, if my sales were more than 1.7 million, if I wanted to say 1, if I wanted to be a number, just indicating that it is more than 1.7 million, I can just say 1. But because I wanted to say something that is textual, I have to put it within the quotation marks. And if not, I wanted to say no, right? So if sales are more than 1.7 million, I want it to say yes. If not, I want it to say no. And obviously the answer is yes, because Bojangles had more than 1.78 million. Now obviously this is not useful because I can see that Bojangles had more than 1.7 million. But what I can do is, instead of writing this function by itself, I can write this function for all my stores. So let's say that I go and create a column saying sales more than 2 million. So I want to see how many of these stores had sales that were more than 2 million, right? So I could say if the sales were more than 2 million, then I wanted to say yes. Otherwise, I wanted to say no, right? So this is a formula that I wrote here. No, obviously, Bojangles did not have sales of more than 2 million. But what I can do now is I can copy this formula over all the way down, all the way to all the way for Zaxby's. So by copying this formula down, and the way you copy formulas that are in consecutive cells, very simple way in Excel is you take your mouse cursor all the way to the right bottom corner, it turns into that black plus mark. You left click on it and you just drag all the way down. That's one way to do it. Or if you had numbers filled in here, there was a better way of doing it. I'll illustrate that later. There you go. And you'll notice that some of these stores are no's and some of these stores are yeses. So 1, 2, 3, 4, 5, 6. 6 of the top 24 chains had sales per store that were more than 2 million. Right? And I could do that by writing a single if function and then copying all the formulas down. Right? So if the sales are more than 2 million, I wanted to say yes. If not, I wanted to say no. Right? Now, let's say that instead of just looking at sales that are more than 2 million or less than 2 million, I want to categorize all my sales into 3 different groups. Let's say we wanted to say if the sales were less than 2 million, we want the sales to be, say, low. If it's between 2 and 2.5 million, we want the sales to be medium. And if it's more than 2.5 million, let's say we want it to say high sales, right? So let's say we want to categorize into 3 different groups rather than just saying more than 2 million or less than 2 million. How would we do something like that? So to do that, we use nested if functions. So by nested if functions, we say we use if functions within if functions. So 3 categories. Right? Oops. 3 categories. So I want to say first is I want to see if the sales are less than 2 million. That's the first check. If the sales are less than 2 million, then I want it to be low sales. I'm sorry, not less than 2 million. Let's make it less than 1.8 million, right? If it's less than 1.8 million, we want the sales to be low, right? So if the sale per store is less than 1.8 million, it's going to say low. If not, if the sales are in fact more than 1.8 million, now we don't have a single result. In fact, now we have 2 other things that we have to do. So we have to do an extra check. So to do that, I'm going to write another if function. I'm going to say if. Now that I've checked if it's less than 1.8 million and I know that it's not less than 1.8 million, I'm going to now check, is it less than, say, 2.2 million? Let's say that's the cutoff for medium. I'm going to say, okay, is this less than 2.2 million? It's another 0. Yep. Right. So we've checked to see if it's less than 1.8 million. If it turns out to be less than 1.8 million, it will be categorized as low. Right. And if in fact it's not less than 1.8 million, it's greater than 1.8 million, but is less than 2.2 million, it will be categorized as medium. And if it is not less than 2.2 million, it will be categorized as high. You'll notice that when I go from one to the other part, I'm putting commas. These commas are crucial. You cannot forget the commas. Right? So let's look at this function. So I think 1.8 might be a bit too high because it begins. So the lowest number is 1.1. The highest number is 3. So let's not make it 1. Let's make it 1.5 million here. And let's just make it 2 million here. Right? So you're saying that if sales are below 1.5 million, they are low. If they're between 1.5 and 2 million, they are medium. If it is more than 2 million, it's high. That's the three categories that you're putting sales into. Again, if it's less, so the first thing that will happen is you take the number and you check, is this less than 1.5 million? If it is less than 1.5 million, the answer is low, you're done. But if it's not less than 1.5 million, the next thing that happens is you check to see if it's less than 2 million. If it indeed is less than 2 million, well, it was more than 1.5, but less than 2, so the answer is medium. If not, the answer is high. There you go. And with this, so I can show you the second way of copying formulas down. If you have a bunch of cells that already have formulas here, what I can do is instead of going here and then dragging it down that way, what I can do is I can go to the bottom right corner and just double click, and the whole column will show up. Now this is not always consistent. Dragging it down is definitely always consistent, but this is it. So this is an example of a nested if function where we wrote one if function inside another if function, and the second if function. So the first if function tells us if the sales are low or not. So if function only has two results, a true or a false. If it's low, it's low. If it is not low, we now have to check again to see if it is in fact medium or high. So that's why you have to write another if function. Then you'll notice that there are some medium sales stores, there are some low sales stores, and some high sales stores. Now if you wanted to find out how many medium, how many low, and how many high there are, you can do that by using the count function. Do you remember the count function? So you can use the count function, but there is a better way of using the count function that we'll talk about right here. Right? Now the OR function. So let's do the count function first, and then we'll come back to the OR function. So what is the count function? The count function, COUNTIF function. I'm going to say COUNTIF, right? So what is a COUNTIF function? So the first part of the COUNTIF function is a range. So I want of all of these values, of all of the categories that you have, I want to find out how many stores had low sales, how many stores had medium sales, and how many stores had high sales. So that's what I want to find out. First thing that I want to do is I choose all the values here, and I say the second part of this function is, so this is COUNTIF. Of all of these numbers, count the numbers that satisfy a particular criterion, right? Now, in this case, the criteria is going to be a text number. So I'm going to say how many of them are the same as, say, low. If I just say low, it's going to look at all of these values and pick out the values that say low. So 12 out of the top 24 had low sales based on our criteria. So you remember our criterion was that less than 1.5 is low, between 1.5 and 2 million is medium, more than 2 million is high, right? So just to, say low sales, medium sales, and high sales, right? So this is where I had the COUNTIF function. So again, the COUNTIF function, you're saying take all of these numbers and count them only if the value is low. Right? Again, because low is a text, I have to put it in parentheses. So let's say that I don't put it in parentheses. What happens? Let's see if it works. No, it doesn't. It just gives you 0 because it doesn't mean anything. But if I put it in parentheses, I'm going to say 12 of these categories, 12 of these companies had low sales. Similarly, I can say COUNTIF. So you're only counting if a particular criteria is met. COUNTIF it's medium, and then COUNTIF high. Right? The same formula, we're just writing it 3 different times. One for low, one for medium, and one for high. So you know that 12 of these will be categorized as low sales, 6 of them as medium sales, and 6 of them as high sales per store. Right? Now here the COUNTIF formula, the criteria that we used was a text-based criteria. Let's say that I want to see how many of these companies had sales more than let's say 1.8 million. Right? So that's a criteria that's based on a number. So more than 1.8 million. Right? How do I find that? Just move this over just one cell. Everything's consistent. So how do I find out? So I can say that, well, I want to count if of all of these numbers, I want to count within these numbers, I only want to count the numbers that are more than 1.8 million, right? Now, how do I put that criteria down? So the way you put that criteria down is slightly complicated. So you're going to have to say within brackets, you're going to have to say greater than, so because you want to look at numbers that are more than a certain value. So you say greater than 1.8 million. So that's 1,800. 1,800. Oh, close the quotations, and there you go. Right. So you remember when you're saying greater than 1.8. Now again, if you don't put the quotations, this will not work. See, the formula will throw up an error. You have to put it within quotations. Even though it's a number, this time you have to put it in quotations. Whenever you use COUNTIF, the criteria is always within quotations. Right? So greater than 1.8 million. So 9 companies had greater than 1.8 million sales. Similarly, I can say less than 1.3 million. So I could again COUNTIF. And say less than 1.3 million. Close the quotations. And 7 companies had less than 1.3 million in sales. 9 companies had more than 1.8 million in sales. Right? So you can write COUNTIF with text-based criteria like that, or you can write COUNTIF with number-based criteria, so greater than or less than, right? And you can also write equal to if you wanted to find out if there is a company that had exactly 1.2 million in sales. So you could say equal to, but you'll get 0 because there are no companies that had exactly 1.2 million in sales, right? So there you go. Now that's the COUNTIF function. So the last function is the OR function. So the OR function is a function that when you have 2 criteria that are removed from each other, so you can, and you want to find the conjunction, that's what the OR function is for. So let's take an example. So let's say that I want to find out all, so I put all of these criteria into 3 different categories. I had low sales, medium sales, and high sales. Let's say I just want to count the companies that are either low sales or high sales. I don't want the medium sale companies. I want companies that are low sales or at high sales. How do I find that out? So I can say OR. So if I write the OR function, I can put multiple logical criteria together. So I can say OR. This is equal to low, So right now I'm doing it only for Bojangles, but then we'll do it for everything. So you'll say it's a false because this is medium. So the two conditions you're looking for is, are the sales low or are the sales high? So you're looking for extreme sales that had either lower end sales or higher end sales. You're not looking for the middle period, the middle portion. So OR puts two logical criteria together. If any one of them is true, then the OR function is true. So the result for the OR function is either false or true. So let's say that I'm going to put it here. Let me call these extreme sales. So, or let's say high or low sales. Low or high sales. Let's say that that's what I have here, low or high sales. I'm going to say OR, is this low or is this high? Right? So if I copy the formula down, or just double click it, so you'll notice that many of these are true, some of these are false. So whenever sales are either low or high, in either of those cases it's going to say yes. If not, true. If not, it's going to say false. And then of course I can say COUNTIF. And say, just count the ones that say true. So 18 companies had either low sales or high sales. We already knew that. Just add these numbers up. But then I could write the OR function and then use the COUNTIF function to count them. Right? And that is the OR function. So this sort of concludes the basic math and stat formulas and logic formulas in Excel, how to use formulas, how to type in formulas and whatnot. There's one last thing that I wanted to show you, and that is a sort of simplified, I shouldn't say simplified, a sort of, if you didn't want to keep track of writing equal tos and putting in open parentheses and close parentheses and all of that. Let's say that you want to use the sum function, but don't want to keep track of the open and close parentheses. What you can do is you can say, okay, I want to use the sum function. So I could start by writing the sum function, right? Go here and say sum function, right? And then I can press on this fx that you see here. And then it brings up a formula builder. Now this formula builder looks slightly different in Excel, Excel for Mac and Excel for Windows, but for the most part it looks exactly the same. So here, if I want to add a bunch of these numbers, so I'm just going to click here and choose the all of these numbers. So just like I did with the formulas, but here by choosing the numbers here, and then I click on done. It writes the formula for me. You notice that the sum, the open parenthesis, close parenthesis, all of that comes up here. This is the formula builder that you have. So you can use the formula builder. If you don't want to keep track of all the parentheses and whatnot, you can absolutely use the formula builder. But I mean, I find it inefficient. Typing in formulas makes more sense to me. But that is always an option that is open to you, right? Okay, so this concludes this video, and I hope this was helpful to you. Thank you.